All right, we are live streaming on YouTube. Thank you, Sarah. And this is the combination education and new member meetup. We've posted in calendar. Hopefully some folks will join us. We have Sarah with us and John Schull. And we're joined by Dr. Rick Williams to hear an update about some of the stuff that he's been working on, which is always very exciting to see. And so I'll let Rick take it away. And Rick, I should also tell you about some of the stuff we're doing in the classroom with open source assistive devices. And e-NABLE's a big part of that, but there's also some more stuff we're looking at.
Good. I would love to see it.
So tell us, what have you been working on? It's always something cool. I still think about that bike chain mechanism that you showed us, I think, the last time you were on here. Yeah.
Yeah, I haven't given up on that. If it's all right, I need to kind of give you a little short summary of how this happened. I was contacted by a local surgeon, and he basically had a patient that came to him wanting help, and she has ALS. Unfortunately, if you have 100 ALS patients, she's the 1% that it is so debilitating that there was really nothing he could do. So he called and asked if we could do something. So I went and I interviewed her. We spoke for a while, and I just really needed to understand what she needed. What can we do? She's lost the use of her hands, and things are deteriorating for her very quickly. And I think really from our discussion, what she wanted, she wanted to be able to feed herself. She wanted to be able to pick up a glass. She wanted to be able to open a refrigerator door, operate the TV remote. I mean, her expectations, the bar was pretty low. So I went to work on it, and I really didn't understand ALS very well. So I wanted to have the surgeon head up the project, and I asked him if he could please do that. And I said, I will work for you. I will build, but I need you because I'm really out of my comfort zone with this, and I do not want to hurt this woman. So if you would guide me and be the leader of the pack, and I will build whatever is necessary, and under those terms, I would agree to do it. He wholeheartedly agreed. He's on some committee, ALS committee, that I was going to try to understand. He also had heard of what we were working with. I had been called by Nova University to come in and show some of the designs that I'd been working on to the future doctors. So we had a whole room full of them, and he had heard about it and wanted to know, if he could see it. Absolutely. There was really not much in the arsenal, the e-NABLE arsenal. That's not a cut at all. It's just that I don't think anybody that I've ever worked with at e-NABLE has ever mentioned ALS or any of some of these other debilitating diseases. So I really didn't know who to contact. So I thought we'd just go to work and see what we could come up with. And right now, I mean, anybody that's worked with me knows I don't keep the best ones are always in the field on somebody. So I actually went and got some of the prototypes so I could show you guys how this thing works. We have two models of, well, actually there's a lot of iterations, but two major models. Those are hydraulic or pneumatic and hydraulic. And the pneumatics are nice because air is easy. However, air can be compressed, as we all know, so the strength is limited in air. It's probably still better than, some of the fingers can handle. I mean, I'm sure, using strong enough ligaments, you can easily break most of the fingers that are 3D printed, but air is, because it's compressible, is limited in strength. Hydraulics, on the other hand, liquid can't be compressed. So it 100-folds the strength of this design. Now, what we did with the design is we're doing it both ways, pneumatic and hydraulic, depending upon the requirements of the wearer. And also keep in mind that this woman has all her digits, they're just dead. They don't do anything. So what we wanted to do was augment her strength. You're going to be seeing the device today that does that.
Cool.
However, I don't have the hydraulics here, but every one of these is adaptable to work both ways. And then what I'll do is I'll go through with you all of the things that can be done. This particular one revolves around synthetic muscle, and everything is synthetic muscle. I know what it looks like. It's a little clunky because this is an older model, and these are from fish aquariums.
Yeah.
These are the pneumatic muscles, and this model also works with hydraulics. This is actually a diving glove. Every time I work with somebody that needs something, we just worked with a young lady that wanted to be a diver and had no hands and feet. So I was learning all about the diving industry, and then found this glove. Cheap, very comfortable. All you do is attach the muscles to it. Don't even need the glove, actually. We have a model that attaches just to fingers and thumbs, uses the same tech. I like the glove for this particular thing because she couldn't get anything else on. It would have been very hard for her. This, she can actually, we built her a rig. She can stick her hand in, and it's kind of like the ones you've seen putting on your socks, where you stretch your sock over a half moon, and then you can pull your sock on when you don't have,
Cool.
So in this case, this worked out very well. The reason these are here is, okay, I built the last hand, and it had 15 servos in it. Now, if you do the math, first off, you guys know I don't like servos. And from a strength perspective, you're talking maybe 700 grams to lift 1.5 pounds for 1 centimeter. I mean, really? What am I going to do with that when somebody has, nothing? These, on the other hand, can lift 40, 50 pounds like it's nothing.
Wow.
Here's the other thing. When you're using servos, that's an amperage. You need about 6 amps. Too much. That's a battery power issue. And also, not do you only have those 15 servos, you also have to sense each of them. How much duress and stress are each of those servos on, so I don't break them? And their lifespan is quite short. They only guarantee even the better servos, the SG90s, for like 2 hours. They're not designed, for long-term wear and tear. I've never gotten a day out of one without having to replace one of the 6 or one of the 15. So these, I haven't broken one yet. And I've done terrible things to this. We even had young doctors putting these on at the university, and they were picking up buckets of sand.
Wow.
So what I'd like to do, I was explaining why these aren't permanent. They will be replaced as soon as I get a new shipment with these. This is a solenoid valve. And each of the fingers will have one of these solenoid valves in it. Right now, we're doing the fish aquarium thing, which means is if I open this valve, the finger will in fact work. If I close the valve, the finger will lock in the position it was last in. Now think about that for a minute. That means that instead of having to build in all of these different things to do gestures of sort with your hand, you can lock it in electronically, especially the hydraulic. It won't budge. If you lock that thing down, it's not moving. And you can pick up an enormous amount of weight. And you don't need any sensors because it's air and hydraulics, which means that if one finger stops, it dictates, because of the science, that the other fingers will continue. It's air and hydraulics. Because it's self-balancing, you don't need any of that electronics. So the electronics get simplified 100 to 1.
Yeah.
You need no electronics. You need no sensors. You need no nothing. Okay? This is what they look like on the patient.
Wow.
Okay, now what I'm going to do, I'm going to fire it up here. And I know what John's going to ask. And I will be happy to answer it because he's going to say, how do you control this thing? Okay, here's how it works. It has multiple modes. And the way it works is, in this case, it can exercise the hand, which is what the doctor wanted. 24/7, this can actually exercise your hand by pushing a button. And I'm going to do that. And it has every gesture you can imagine as well. Because of these, sorry guys, I'm just reaching over here. Okay, I'm going to close the hand. Now I'm actually fighting it. I don't want it to close.
Wow.
Now I'm going to open the hand, close the hand. Now, say I wanted to hang on to that, but I don't want to use power anymore. I would turn these valves off. Look. Right. Now, if I release the valve,
wow.
Same with the thumb. See the simplicity? Super simple. Now, how am I controlling this? John? Bluetooth. This little Bluetooth transceiver, in her case, goes in her sock, and she pushes it with her toes. It doesn't matter what you push it with. If you squeeze it, the hand closes. If you let it go, the hand opens. Incredibly strong. And the first thing you would probably say is, yeah, maybe you're helping it. Well, I used to bring out Mr. Harvey here, and Mr. Harvey's job was I put the hand on him, and I was able to pick up very heavy things like gallons of milk. You probably can't even hear this thing work. And this is the pneumatic. See the muscles?
Yeah, what are those tubes from?
The tubes are 3D printed. Sort of. Okay, sort of. You 3D print a mold, and then you take the mold and you make the tubes. So you pour silicone in the mold after you 3D print the mold, and you make as many as you want with one 3D print. I'm going to release it now.
And then what kind of control system is that tethered to?
Bluetooth, which means you can use anything you want. Your phone.
On the hand side, like, so the hand
on the hand
has...
side, the hand has a motor. I got to tell you guys about this. This is the coolest part. A motor. Now, here was the problem. This is a 3.5 volt motor. That's all you need. There's two kinds of motors for this. Try your best to find a motor can run forward and reverse by reversing the polarity. A pump, not so much. Pumps will go one way. They'll either be vacuum or they will be pressure. But because of the way most pumps work, it loses 70% if it goes the opposite direction of its strength. So we took the motor, took off the pump, made our own turbine for the nose of the pump. It can run in either direction, which now means instead of two motors, one for pressure, one for vacuum, you only need one. So that cut us another 50%. So we've gone from 15 motors to one. Not only that, each servo is 5 volts. This is 3.5 volts. So on top of that, if you're going full hydraulic, there's a second option.
Then you use a peristaltic pump?
A peristaltic pump. You hit it on the head because peristaltics are designed. John, do you ever watch the movies when you're having heart surgery and they have those pumps that pump your blood? That's a peristaltic.
Pump is, yeah.
Okay.
Yeah.
And that is its job, basically, is to move fluid. It doesn't do well with air. And the peristaltics can be 3D printed. We've already got the 3D print working. We can 3D print them all day long. They're cheap. And what we use on the paddles that go around the peristaltic is we use, we did this on purpose, but we print ball bearings. And we put BBs in them. And that's what spins inside the peristaltic pump that pushes the liquid. And we're moving a lot of liquid. Now, I'm having a little problem finding a reason to use the peristaltic now that we've got this new head. Because this head generates a lot more pressure than the peristaltic does, but the peristaltic's simpler, lasts longer. It's just simple. Now, I'm going to move on to the next problem. Her next problem was, even though this thing is making her, even though this thing is actually helping her muscles because she can put it on and let it run 24/7, it wasn't regenerating the nerves, but it was eliminating a lot of the atrophy that she was having. So what we did is we took that a step further and we put in, this is actually built into it. This goes on the inside of the socket. This is a TENS unit. Very, very strong TENS unit. We've souped it up a little. This goes on the inside of the socket and exercises and is making the nerves come back. So it's not only working the muscles and the nerves, but also real exercise, real actual exercise. That's not the end of it yet. And I'm sorry, there's more. This is the socket. You're gonna love this. And it has infrared light woven into it. So the socket itself is helping to regrow the muscles with these infrared 1500 nanometer IRs. Everything I build has eyes on it too, by the way. I have to do that. I don't know why. But this thing is only part of it. And lastly, what we do is she had terrible tremors, you know, with the tremors. The doctors, after they put this on her, so we built these gyroscopes. Oh. This thing will power up with this little wheel, which will spin it up and completely eliminates the tremors. It absorbs them.
Cool.
Yeah. All that goes on. Each one of these is an item that goes into the arm. Some people don't need them all. She did. She needed all of them. And my major unit is with her now, and the doctors are testing it at that clinic. And they said the results are fascinating, is what they said, because all of these things seem to be going after the nerves and the muscles. The tremors have somewhat subsided, so we've actually removed the gyroscopes from it, which is good news. This little thing we got for $11, and it was online, and it's very powerful. But what we did is we set it up to where we could snap it. This is the conductors. We can snap it right onto the arm, and then it weaves into the entire arm and works all the arm muscles, wrist muscles, and the hands. And then this is just gooey sticky to stick on the arm. We didn't make this, we bought it. $11. We were, pretty thrilled with that. Super strong. All we did is up the coil a little. Because she couldn't, it was about making me crazy, but she couldn't feel it. So we had to step it up. Now, anybody that's, gone to a high school, basically a high school science class has done this, right? So, I just want to go through how cool the hydraulics really are, because on some of the hands, we've converted most of our hands. We've converted them to hydraulic. And it works remarkably well, even without some of this other tech. And we've also done this. We've got these machined.
Oh, nice.
So these are for the upper elbow. Very, very strong. Very strong. And this is a push me, pull you here. So you can put pressure here, vacuum here, pressure here, vacuum there to make to make basically the thing operate. Super, super strong, more than enough for an elbow. We put one on each side. But the pump has been the big deal, and we can't really get it too much.
How bulky is the pump side? And then battery pack wise, are you running that off like some sort of LiPo next to it?
Yeah, the equivalent of 4 AA's is all it needs.
Wow.
Because it only needs 3.5 volts.
Yep.
So we double it up with, it actually could run off 2, but we double it up to 4. And then we make them rechargeable. It has a charging unit that comes right off a USB port. So you
Yep.
can charge it off the same thing. Now, because it's Bluetooth, Ian, understand that that means anything can operate this. A phone, a remote. This little remote is nothing more than a dummy switch. It's a stupid on-off. And it's able to do all those things. Like I said, we put it in your sock. And then you just plug this thing in to charge it.
Okay, so there's no control board. You're just supplying power or not supplying power.
Sort of. You've got to look at each finger now and
Right.
then replace this with these, which means if you want gestures, you just disable either you disable them while it's open or you disable them after a grip because they're normally closed. And because it's an NC, it's going to shut when there's zero power.
Yep.
So when there's power, they open unless you override with a micro switch, which powers it down. And we're using these little guys. I think I got a whole bag. These little fellas. And that way you need 5 of these to power down each finger. And they fit right on the control box, which is right here. They'll take the place of this. These will be removed. And then the control box will have those switches. So if you wanted to have it like this and hold on to it, you just disable these two, let it open or not, doesn't matter. Remove all power, and it's going to stay that way because it has to. It has no choice unless there's a leak. So if nothing's leaking, it will continue to hold. Now, we've got one in the other room that's been holding over a month.
Wow.
Yeah. That's a hydraulic, though.
Yep. And so you don't need, they're just simple power to the solenoid, simple power to the motor. Nothing in the loop other than a battery.
No. And then when you want to reverse, go from vacuum to pressure, you just reverse the polarity.
Change direction. Yeah. Super cool.
And how does the thing stay on your arm? Remember these?
Yeah.
What is that?
Chinese finger torture. Can't get your finger out. We're building these to hold the device on because she can't get into it very easily. So this won't come off. You have to push in, and then we put a thread in it, and then that opens it like that.
Cool.
So I've shown John seen that before because we were using them on animals.
How many iterations did it take you to get? Because this is a bunch of feature development.
A few.
Yeah.
Now, when you look at it from the perspective of like an Accutronics, okay, do I like these? Absolutely. You know, these little microlinear actuators. Oh, they're great. The power requirements are just too high. You start putting 5 of these in a hand, now you've got to sequence each one because if you hit them all at once, they're going to kill your power supply. It needs too many amps. They lift more, they're strong, but we're back to the power requirement. And the other power requirement is once you park it, then all bets are off. It knows nothing anymore. That's why I like the hydraulics and the pneumatics. Yeah. Because how you park it, you get to choose.
Yep.
And you don't even have to power up to release. You just basically
so what is
turn the switch.
Has this got you thinking about the next thing too? Like this makes me think about like a wearable chair and like how much you could scale this up for other like impairments.
I have most been focused on doing this, but I can see pretty much everything you're saying would be very easily done because what you're doing is you're removing the complexity that you need. The more, everyone knows, the more stuff, the more motors, and when you're doing gears and plastic, you know, like a servo, you can't expect the longevity to be that good. And if you do something to that and you overpower it, you're going to first off break the teeth, or you're going to break something. The capiston's something's going to break. This doesn't break because there's nothing to break. Everything's soft. There's nothing unless you physically cut it with a knife or blow it out somehow. You don't need sensors of any kind. You could put them in, It'd be so easy to make a synthetic muscle, okay, and then blow it up. And then when that little balloon got X big, you could hit a kill switch. And guess what? That would cover all 5 fingers.
Yep.
Because it's all self-balancing. The hydraulics, by their nature, are going to balance across everything they have access to, and they're all hooked ultimately together in a pod. So what you're basically doing is, if you wanted to do push-ups like some of the mainstream arms do, they brag about that. Okay, well, his doesn't break. Well, wonderful. Neither would mine. It's not going to break. It might give a little, it ain't gonna break. There's nothing to break except to tear in the muscle, and it's all silicone. And you can make it faster because you're doing it from a mold. You're dealing with silicone.
Is there any trick there for how you connect the pieces once you've molded them so that you get a
Not
good
really.
seal?
No. You're basically, if you look super close, you'll see that as long as you adhere to the tubing. Now, this one has a much larger tubing than the other one because I was experimenting with the different sizes. Of course, that came back and bit me because, as you can see, I had the large tubing and the small fitting. So I have to go back now and see what I would lose in order to go back to the smaller fitting. Probably not much. Because the airflow, especially in the hydraulics, as you know, you can take it down quite a bit as long as it's not restrictive. These are in no way or form restrictive, but sometimes when they're smaller, you have to increase the pump just a bit when you're doing the vacuum. But I'm finding nothing that's gotten in my way yet with this technology. And quite frankly, the beauty of it is that those 4 AA batteries last so long because after you've moved, everything shuts down.
Yep.
There is no more power, none being used.
John, do you have a question?
I do. I have a couple. First, Rick, congratulations. As ever, it's mind-blowing. Number two, you say the patient, the woman, has one of these rigs, and a clinic where is working with her?
St. Petersburg, Florida.
Say it again?
St. Petersburg, Florida.
St. Petersburg, Florida, which is where you are also, yes?
Yes, yes.
That's huge. Okay, and by the way, do they understand how it all works?
Not initially, but they're very smart people.
Yeah.
And they really care, and they want to do this, and they listen. And once they put the thing, we always put it on them. And I don't have to explain anything after I put it on them. Once they wear it, the explanation's kind of over. They go, oh my God, this is so stupid, easy.
Yeah.
Of course, they have recommendations like some of the bulk, and I get that. Unfortunately, in order for the synthetic muscles to have a little strength, you have to have a little bulk, and there has to be a hard surface on a synthetic muscle because the muscle has to turn this way. You don't want it growing out this way. That doesn't work because you want the finger to curve.
Sure.
So the top of the muscle has to have this accordion kind of look to it, and then the bottom has to be. You can't let the bottom extend, and that makes it bend.
Sure.
Very naturally. And we put these over like the finger because if they have no fingers, this works too. All you got to do is have something to hook onto. So we use this finger we've been doing. We haven't put it on anybody yet with this technology, but as long as it's got something to hold on to, it really doesn't care.
Okay.
And it made this easier because now there's no pull string.
Yep. Right. So are these, it looks like a breakthrough system to me. You are notoriously bad at documenting, as we know.
Horrible at it.
That's right. Are these guys going to put the story together?
I hope so.
The clinicians?
They've got a lot of work to do, and that was part of the deal because I know how bad I am at that. What I do want to do, though, is I want to use OpenSCAD and get all the molds in there so people can make different sizes and shapes. Because once we do that, they can sit there and change the variables. I like the idea of making a mold that is reusable.
Of course.
You do what you put it's like a PAM almost. Like you put in a frying pan in the mold, and then you put the thing together, and then you fill it up with silicone, and then it pops out, and guess what you got? The whole muscle.
Right.
We've
had people. I've had an intern, and Peter Binkley spent a year working on it. You're working with someone with ALS, but there are lots of people who've had strokes and their hands are clenched. And what people have said is there a device that will open them up, put ongoing pressure? No one
hers is clenched also
well enough, as far as I know.
Yeah, and ALS, hers is clenched.
This is that also.
Yeah. That's the first thing it tends to do, John. It's really bad. We've even been contacted by a lady with trigger finger that after the surgery, it didn't work, and she wanted to do it just with one finger.
Right.
And I don't have a problem with it, but you can build these things, as you can see, with however many fingers you want.
Right.
Anybody can make it. I mean, it's just super, super easy. The glove was done mostly for her to be able to get it on. She has a partner. Her partner is an ex-physical therapist, which really helps.
Combination.
Yeah, it is. So I've been working with her partner to help her understand how to get it on and off easily. And of course, it's not easy. Whatever she does is difficult, but they're very private, and I respect that. But the partner, she has to rely on a lot now, and of course she doesn't want to have to. She wants to have a little independence, and that's perfectly fine. But we're trying to, as Ian said, we're trying to get the pump sizes down. The Paraceltics are very nice for size because you can stack them. So if you don't have enough, you can stack them like pancakes, basically. We have one Paraceltic box in the lab. It's got 8 stacked, 2 sets of 4. And I don't really see it helping as much as I'd hoped. Because the other thing is you can't convert the Paraceltics to use pneumatic. It's right. Hydraulic only.
Right.
So that's, in my mind, a disadvantage. But
on the other end of the tubes, it's the same silicone mold, the same tubing. You just adapt it to a water or air compressor.
I don't know. The Paraceltics just don't seem to gulp the air the way a turbine does.
Oh, but I mean, like the tubing. Could you retrofit that part on the wrist? It swaps out between the two, or is it all a custom?
They're different shapes and colors. Yeah, we actually were trying to make. We like the Paraceltics because they're nice and flat, and it's easier to hide on the arm. So we were kind of hoping to use it for that reason too. Not only is it super simple and they don't break much, and you could 3D print them, but because they're nice and flat, you don't have that big camel hump that you do when you have something that's cylindrical.
John,
I'm surprised you're putting the pumps on the arm. You could mount them on the chair, the wheelchair, et cetera, and just, put everything that doesn't have to be on the body right nearby. This woman's not going anywhere anyway, right?
This is how it works. It's all you need. Wherever you want it, you could have it on your belt.
Right.
You could put it in your pocket. You could put it on your hip. You just plug this into the power pack. All you need power for on the glove is for the fingers to open and close the
solenoids.
To open and close the solenoids. So I've been putting the solenoids on this little bank like this. So this is like a solenoid bank. And so like if they had a thumb and a finger, this would be really cool because some people want to do this and that's all they care about, So configuration wise, yeah, this tube and some very, very thin wire is all you need. So I'm just trying to make it to where I'm trying to make something somewhat universal that would allow me to basically do one finger, two finger, a whole hand. You got no fingers. You've got fingers, they don't work. So I'm trying to figure out a way to make it more of a modular thing, so you only put on what you need.
Yeah. Super cool. What are you calling it?
Fred, I haven't even thought about it. I haven't really given that much thought. We're just right now kind of in a holding pattern, waiting to see what the doctors are going to say. And for very good reason, I wanted them to be the leaders on this. I didn't feel comfortable that I knew enough to deal with somebody with those kinds of issues. And there's going to be more coming. We've got a lot more parts that have to go into this, because pretty soon she's going to, for instance, start losing her hearing. And so right now we're working on a thing to fix that, because there's no way she's going to get cochlear implants. It's not going to happen. So we've got a new device for her hearing now. It's basically a transducer that goes around your ear, and it fits onto your skull with, you have to shave a little patch, and it uses bone conduction.
Bone conduction, super
uses
cool.
the conduction in your bone to basically transmit all the sounds and it hooks to your phone. Yeah.
That's super
it's
cool.
Bluetooth into the phone.
One of our early hackathon things here was similar. It was like a headband that goes on the back of your head for factory workers. And if there's a loud enough sound, like something falling that you have to turn, you would be behind you, it would give you a vibration to give you a 3D sense. That's super cool, doing the bone conduction as a low cost cochlear alternative.
Super cheap to do, Ian. Super cheap.
Yeah.
And so we're working on that. She's worried about her eyesight. We're probably going to have to get something commercial for that. Maybe an Okron or something of that nature. But we're doing the best we can for her, and we're trying to use the phone because it's something that she's really good with, her phone. So,
Right.
But as of now, I mean, she can pick up a gallon of milk like it's nothing.
Wow. That's super cool. And so how do clients like this find you? Is it through the medical side? Is it through the research lab? Is it through word of mouth?
Yeah, kind of. I don't know. It's not like I advertise, because I don't. This particular case, this surgeon called me because he knows me. He's an old friend, and he's just the most decent man I think I know. He's a really good man, and they all wanted to cut on her, which would have meant she would have had a cast for 6 months. Now that's about 6 months more than she's probably got. And in his mind, he just couldn't do it. He just couldn't. So he just was looking for something to help her in the interim, to give her the best shot she can have, to do the most stuff she can do in the time she's got left. And I see nothing wrong with that. And so what we did was he kind of just spitballs things. He calls me, is there a way? And initially I was going to do a standard exoskeleton, but those are a problem, because in order to get the leverage you need, everything has to stick up so high, and it gets caught on everything, because a lever is a lever, and you need a certain amount of clearance to make exos work. I'm not knocking them. It's just the physics of it, unless you have enough. I mean, maybe with maybe with the right hydraulics, you could get away with it, but at the same time, they're just too bulky. So we were looking for a way to do this inexpensively and find something she could do herself. Because if she can't put it on herself, she's going to be upset. She wants to do everything herself. That's okay. So a glove made the most sense for us at this point, especially when the glove is just an add-on, really. You take it or leave it. The glove doesn't need to be there.
No, I love the human-centered design at the center of this to solve these problems that I haven't heard anything solved quite like this. And I think John was asking the right question, like, what do we need to do to support you getting this documented into like an instructables guide so that other people can apply it for very similar domains with the same problem.
I would love to see more people give the hydraulics and the pneumatics a chance. I mean, you guys all know how many times I've been laughed at for this because it just sounds too silly. But what it really does is it simplifies. It's not more complicated. It's not more expensive. It's not any of those things. There are problems like the pumps. Anyone could do this with multiple pumps. You'd have to have one pump set up for vacuum, one set up for compression. But that's complexity. If you can fix the pump and make it work 85 to 90% as well in both directions by reversing the polarity, now you've beat that problem and you don't have twice the hoses. You don't have twice the anything.
John.
Your demo involved a syringe, pushing and pulling the syringe. You must have considered a linear actuator, because it's not like you need continuous throughput. You must have thought about a linear actuator that would simply push a syringe back and forth in order to do the...
Oh no, the pump, all I did that for was just to show you that there's a lot of ways to skin a cat. These pumps, there's no syringe on this.
No, I understand. But you were just complaining about the pumps. And I'm wondering if a pump is needed for this system. For example, what about a syringe driver as the motive force?
I don't know that it would be enough. You'd need a lot of travel. And most of these linear actuators are, like, for instance, this one, I think you only get I think this linear actuator only is a ½ inch. I mean, it's just not a real swing on this thing. Anything's possible. I mean, but what you've now done is you've opened the pump up for leakage because the syringe is going to start to leak or whatever. With an actual turbine doing the pumping and the compression, plus as you pull the syringe in and out, sometimes you might pull it too far, boop, and then the thing gets worn. And I don't even know, you'd have to have a pretty good sized syringe to equal the pump. It'd take a pretty awesome syringe.
Just a thought.
It's not a bad thought. I mean, anything's possible. If you stop and think about it, this little thing here is technically a syringe.
Yeah, I know.
Technically it is. I mean, it's a little syringe. That's all it is. And you're basically just going. If you put a syringe on each end of this thing, you basically have a full hydraulic system.
That's what I'm saying.
I don't know that it would be enough for someone to wear every day, because that's a pretty big swing you have to have just to run this little thing. Look at the difference.
What strikes me is that this unit, once you're talking about hydraulics, there's a water reservoir, etc. I'm just thinking that there are a large number of people who are in wheelchairs. They're in mobile, metal, sometimes motorized devices that already weigh 1,000 pounds. If you add a 10-pound hydraulic unit bolted to the chair, they're not even going to feel it.
You're totally right. Yeah,
right.
You're absolutely right. And that could be done also. I'm trying to find a way to make it as small as possible, because it can always be made bigger.
I'm not saying make it bigger. I'm just saying.
No, in a chair though, you could have multiple. You could have a compressor and it would be much easier. Much easier. You've got the power supply. You've got 24-volt batteries in those things. You've got everything you need. The power, everything's there. So you're absolutely right. And scaling anything up, in my mind, this is totally scalable because there's nothing stopping you. There's no disadvantage to scaling up. So if we can get the small scale to work, the big scale is
absolutely
totally
cheaper, easier, better.
Full EXO, you've got the template for the proof of concept. And it sounds like what you need is like a couple interns to write documentation. That could be a good Lumio proposal to try to get you, like, a student from somewhere would be fascinating. This is like a great pitch. This hour we could probably recruit someone to help you, like with the writing it up part.
I think it'd be awesome if you could, but I'm
would you work with it? Would you work with an intern?
Of course I would. I'll work with anybody if they're polite.
Do you think that you could do this over Zoom too? If they weren't there with you, you could show them enough that they could aggregate your
I don't see
resources
why
into a
not.
guide? Yeah.
Yeah, I don't see why
Hmm.
not. We could basically, I think, I think if you got an intern and you explain how to build the mold, explain to them. I mean, not everybody knows how to use silicone. Neither did I. When I started this thing, I started watching YouTubes on how to work with silicone. I even went out and bought one of those stupid kits, you know, the IR kits on
Yeah.
how to make jewelry. I didn't know what I was doing,
Yeah. Totally.
and I went and bought the resin kit,
Yep.
and because you with that you can make really nice hard parts, you know,
Yeah.
like turbines.
Yep.
You know, it works, and they're very strong. And let's face it, you know, some of us don't have the big money to have a big 3D printer, and running, you know, a week just to find out, you know, to get your part out. If I can create the part with resin like I was doing in 10 minutes,
Yeah.
it's so much easier.
That's cool.
Well,
Yeah, and the voltages are what's really important. You've got to keep the voltages low because you don't want to be hanging 24, you know, excessive voltages on people.
Yep.
And one of the reasons that I'm not using any kind of, I'm not using a triggering system that uses, you know, like the skin conduction, myos. I'm not using that because they're just not reliable. They're just
Hmm.
not. I've had terrible luck with those. And doing it
everyone
this
has.
way with whatever they have that works, the Bluetooth just works. And you don't, you know, you can charge this little thing. I think it takes 10 minutes for this thing to charge, and it runs for days. And we put, like I said, we put it in her sock.
That's so
All she
cool.
does is curls her toes. And it, ding, ding, ding. Super dumb, super easy.
Well, if it's stupid and it works, it's not stupid, right? That's a
Right. Rick,
But
it's true that anyone can watch YouTube videos, but the real question is, could we imagine a circumstance where there was an intern who got all of the components from you, because you've already done the sourcing? You gave that person a kit and you said, here's where I got these from, but you don't rely that to them to figure it all out. And you say, now we're going to build another system. And they learn how to build the system, and they videotape it as they're learning and as you're explaining it. And then they're in a position to create a manual and a bill of materials and a demo assembly video. And they're no longer dependent on you, and you underestimate the amount of background savvy you have. You say it's the voltages that are complicated, but you know, if you say here are the parts, here's the components, here's what you connect, they don't have to understand Ohm's law. They don't have to do the voltages. Their job is just to document the product so that other people can do it. And I think that would
I think
require.
you're onto something. We've been using these breadboards, which make it super easy because with these breadboards, you just plug the little wires into the things. Takes all the hate out of it.
Well, but that's not the point. There's no breadboards in the final product. You use the breadboard in designing. What the trick is to take all of your R&D and now say, here's the kit for making another one of these. Once someone has that, they can begin tinkering and, you know, learning what they need to learn in order to make modifications. But being able to replicate the device, I think, is the low-hanging fruit and does not require that they deal with breadboards or deal with Ohm's law or anything. It just it makes it into the kind of task an intern could do. Now, I think,
Yeah, it's
Ian, I'm not convinced that that could be done remotely. Unless Rick is prepared to ship all of the components and spend a lot of time pushing cameras around.
Or if Rick can give us a spreadsheet with the bill of materials, I'm probably there's half a dozen maker spaces that I could think of that could find a student interested.
yeah. I mean, the thing that would be the easiest is let's build one finger. You know, just to
Great.
take the complexity out. Let's build one finger.
Okay.
And then all you do is take that one finger. When you want to build two fingers, you just put that one in the hose, put it right in series, and now you got two fingers.
So Rick,
And
Ian, find that student. That's an internship we would support.
Yeah, I'm writing it up.
so I appreciate you guys hearing me out.
It's fantastic work, Rick. It always is. But I got to say, this was a really good, organized presentation. Congratulations.
It's probably
Super
the brain
cool stuff.
damage from the heart attack.
Interesting.
I'm sorry that I've kept my video off, but I really enjoyed this presentation. Thank you.
Rick, always so inspirational to see what you're working on. I feel like we need to hang out more often. Like this is always like blows my mind with you're pushing the edge of what's possible with this stuff. And any way we can help like use your research as a lever and get it out there to more people. I would love to talk more about ways we can help you with the documentation side.
Yeah, and once again, I think you guys will find that once you look at the how to make the molds, they kind of make themselves. It's like a print and pour, and I'm sure there's an awful lot of room for improvement on making the synthetic muscles. I'm sure there's a lot of people that are trying it and doing it, and they're probably doing it way better. But it's a balancing act with the bulk, because there is a little bulk still to synthetics, and making them nice and small but still strong enough is kind of where the compromise comes in.
But
I mean, I've tried making them smaller, and
you found the zone.
Yeah,
and it's hand size, so it's a really good fit. All right, to be continued, but Ian, I think you're right that it's a great opportunity for the right student, and
or a
this
team
is
of students across institutions.
What's that?
Or a team of cross-institution students.
Yeah, but I've more experience working with Rick than you do, and this is a particularly well self-contained, coherent product. Capturing this thing in an efficient way while we've got the chance would be great.
Awesome.
I'm happy to help. Whatever we can,
Okay.
we can do.